So hi everyone, welcome today to Data for Everyone, an introduction to spreadsheets. My name is Justin Dela Cruz. I'm the Associate Director of the National Center for Data Services, which is part of the network of the National Library of Medicine. Sarah, you want to introduce yourself?
Yes, hi, I'm Sarah Gonzalez, and I'm a data librarian with Northwestern University's Galter Health Sciences Library and Learning Center.
And thank you everybody for joining us. So today we'll talk about some basic concepts in working with data, including terminology, some things to do in spreadsheets to get started, including making a simple chart. And then we'll leave the discussion with a bit of resources for you. So anything you want to follow up on in this talk, you can find through extra resources we offer through NNLM. And we'll also list courses and resources from other organizations at the end.
Great, thanks so much, Justin. So again, welcome everyone today to Data for Everyone. And if I could have the next slide. So the NNLM is the network of the National Library of Medicine, and it is an outreach program of the National Library of Medicine, which is an institute of NIH. The National Library of Medicine is the world's largest biomedical library, which maintains and makes available a vast print collection and produces electronic information resources like Medline Plus and PubMed. NNLM is a program of the NLM and is comprised of 7 regional medical libraries, or RMLs, 4 offices, and 4 centers. Northwestern University, that I'm representing today, is located in Region 6, and the university also hosts the NEC, NLM's National Center for Evaluation. NCDS, the National Center for Data Services, which Justin is representing today, is hosted at NYU and is in Region 7. And next slide, please. So to kick things off, we would like to ask you, what do you think of when you hear the word data? So please take a few moments to put your associations with the word data into the Slido, which you should see now. This is kind of a free association, so any words that come up, please go ahead and enter those. Excellent. Thanks for using the Slido, everyone. Seeing a few comments in chat too. Yep, absolutely. Yep, stats, numbers, facts, information. Proof of usefulness to the organization. That is a great contribution. Yes, thank you. Yes, definitely all different types of data. Okay, and then the Slido. Let's see how the results are doing. We have 60 contributions. Thank you, everyone. Let's see. Are we displaying the results visually, Justin, or can we?
Are you able to see that if I drag it over to that screen?
I don't so far, but let's see. Let's see, a couple more things coming through. Oh, there we go.
I actually don't know. I guess it's hidden from you, from your view, if I'm trying to share like that.
Yeah, well, sorry. It's a neat way to collect your responses, though. So thank you for participating, and we may have a couple more chances to participate in the Slido later on. Okay, but as I mentioned, so we did see some things in chat, facts, information, numbers. Oh, the audience is seeing that. Okay, good. That's great. So yeah, thank you everyone for contributing. Lots of different ways to conceptualize data, and they're all relevant. They're all valid. So that's exactly what we would like to think about today. So now let's move on to our learning objectives for the day. So our goals today are to define common data terms related to health data, to prepare a spreadsheet for creating a simple data visualization, and then to identify further learning opportunities for working with data. So next slide, please. So first, let's talk about some common data terms. And next slide, please. But also, to set the stage for that, we'd like to acknowledge that data is all around us. Every day, and in many ways, whether we're aware of it or not, we are generating data or working with data in some way. So perhaps we're looking at numbers in our health apps, noting how many hours we slept or steps we walked. Maybe we're looking over the metadata of something we want to watch on a streaming platform, noting the cast list, description, ratings, etc. Similarly, we could be looking over the descriptors of something we would like to purchase on a shopping site, noting the cost, description, whether the item is available in a variety of colors, sizes, etc. Or maybe we're wrangling a big event in our lives, like a wedding, and keeping track of guests' names and addresses, food and flower orders, gift registry items, and more. So in each of these scenarios, we're collecting, evaluating, and making decisions for our lives based on data. Next slide, please. So now let's move on to some key data definitions. It can be helpful to start with basic terminology to differentiate data itself from some of its associated concepts and terms. So scientific data, according to the NIH DMSP definition, or Data Management and Sharing Plan definition, is the recorded factual material that's commonly accepted in the scientific community as of sufficient quality to validate and replicate research findings, regardless of whether the data are used to support scholarly publications. But in this class, we'll start by focusing on other more general types of data, such as the examples from the previous slide. Data is something people tend to work with in stages. So first, it must be collected and recorded. Data input can be defined as a way to capture or record the raw data. Examples include health indicators that are entered into or automatically recorded by a health app, or downloading a list of last year's Amazon purchases. The next stage of working with data is data processing. Processing involves converting the recorded data into a more meaningful form. So examples include tweezing out the important information from a downloaded list of purchases or invoices and placing those pieces of information into a spreadsheet. So the things I might like to pick out and analyze in such a scenario could include product names, prices, dates of purchases, and whether the item was a gift item or a personal purchase. Next slide, please. So here is an example of what a spreadsheet containing such tweezed out shopping data from invoices might look like. Based on the particular budgeting questions that the shopper would like to answer, they can construct a spreadsheet with just a few columns, noting things like the product name, how many of each product was purchased, the date of purchase, the unit price, the total price, and whether this purchase was intended as a gift or as a personal item. By examining these column names and brainstorming a bit, we might already see some potential questions that this data could answer. Questions such as, how much money did the shopper spend on gifts in a given month? So these ideas then will lead us to our next group of definitions. And next slide, please. Data analysis is the process of extracting meaningful information from data. It can involve simple sorting and counting, or more complex calculations. So some examples are included on the slide and include things like determining from the shopping data whether more money is spent in one particular month versus another, or determining how often repeat purchases of items happen to see if a good discount can be achieved by using a subscribe and save type of feature. Metadata is information that describes, explains, and otherwise contextualizes the data. The column headers in the shopping data spreadsheet, for example, are an example of metadata because they describe what is being recorded, such as the product names or the prices. A variable is any type of symbol that represents information. So in addition to being metadata, The column headers in the shopping data spreadsheet are variables because they symbolize the shopping data that's recorded in each category. So variables can be found in both quantitative and qualitative data. And finally, a database is an organized collection of data stored electronically. The shopping data spreadsheet is an example of a very simple database. Databases can also be much more complex, storing multiple tables or multiple spreadsheet-like listings of information and hundreds of variables. Next slide, please. So now let's move on to the how-tos of setting up a spreadsheet. Commonly in studies, data is organized and wrangled in a spreadsheet format. It's helpful to understand basic terminology commonly used in these spreadsheet-like settings. A spreadsheet is set up according to a grid consisting of rectangles. Each individual rectangle is a cell, and each cell can contain some type of data, which was referred to as a value. Common formats for the values are numeric or text or date. Columns run up and down on the spreadsheet, and they're generally formatted to contain the variable as their column header or column name. The variable denotes the name of the data value category that will be collected. Therefore, all values running down each column of a spreadsheet should have the same format, such as date or numeric or text, all the same per column. And each cell should only contain a single value. Rows run from left to right across the spreadsheet. And in spreadsheet settings, rows are generally formatted to contain the instances or observation, which is the thing or the event about which you are recording information. Each instance of observation can consist of recording the values for many different variables. And next slide, please. So kind of a part 2 here of how-tos of setting up spreadsheets. While setting up your columns in a spreadsheet, it's best to set up the data type or format that each column is meant to collect as soon as possible. This is done by selecting your column and right-clicking on it, and then choosing Format Cells from the menu. The most common format types are text, useful for data like product names, personal names, basically anything that must be recorded in words. Next is numeric, which is useful for simple numeric counts of things, prices, age, basically any data that is recorded in a number form. And then there's dates, useful for recording dates, of course, and sometimes date and time. So when you open the options in your spreadsheet program's date menu, there are many to choose from generally. So be sure to look them over very carefully and choose the date or date and time format that will work best for your project. Okay, and next slide, please. So here now is a visual example of data terms that we have just discussed. So each column in the spreadsheet has a column header, which is also its variable name. Then the columns run down the spreadsheet while the rows, or instances of observation, run across. Unique data values are recorded in the individual cells, and the columns are formatted specifically to their respective data. So such as date data being recorded in that month, day, year format, prices being recorded in an accounting format with 2 decimal places, and variables that must be recorded in full written words are stored in the text format. Okay, and next slide, please. So now, this is a good time for us to take a knowledge check. We've already learned a lot about data just in a few minutes, as well as some associated terms. So as a check, please type in the chat the letter, or actually, sorry, use the Slido for your response. I'm sorry, they're not done well there. There should be A through D. Your response for the following question. Which of the following are true of data variables? Are they symbols that represent some kind of information? Are variable names, are they typically recorded as the column headers of spreadsheets? Or variables can be found in both quantitative and qualitative data, or D, all of the above. So I'll give you a moment if you want to check out the Slido. And yes, funny that I don't see the Slido, but I'm hearing that you all can. So which of the following is true?
Yeah, we do have a lot of responses for all of the above.
Excellent. Okay. Yeah, thanks for participating, everyone. And yep, that is the answer, all of the above. So variables represent information, typically stored as column headers, and they can be found in both quantitative and qualitative data. Great. Thanks so much for participating, everyone. And so now I will hand it over to Justin.
All right, thanks so much. Let me go ahead and stop that poll. All right, so we're going to talk a little bit about visualizations here, and then we're going to have a brief baby step demonstration of gathering data and putting it into a spreadsheet and then making a visualization from the automatic chart tool that we have available. We're going to use Google Sheets today, so I'll show you that tool. It's a very similar process in Excel and other programs. But here on this screen, I know some of the font is kind of small, but we wanted to give you the visual of examples of different data visualizations that have been made out of everyday data. So there is a Reddit subreddit here that's listed on the link you'll find from the slides. And this Reddit user recorded data that was likely recorded through a fitness tracking app as they attempted to bike 1,000 miles in a year. So you can see the top chart here is showing the date from left to right from the January of 2024 through November of 2024. On the left, you have going up and down the y-axis, the cumulative distance in miles. And the goal is the dashed line at top, which is at 1,000 miles. So you can see the progress they charted through a little bicyclist that's going stepwise up through the months and charting the cumulative progress for their distance. It looks like they do basically reach their goal. Bottom left is a bar chart showing their average speed. And this is mapped visually to the increases that are displayed above as well. So it's a neat sort of interactive visualization you can see happening over time. And you can see there are speed mapped, average speed mapped on the lower left. On the bottom right is a pie chart showing the type of ride as a percentage. So this is tracking if it was a commute, if it was an errand, or if it was just for fun. I'm going to open back up the chat in case I'm missing anything there. Oh, that Reddit is your husband's favorite. That's great. So this example illustrates how data is found in everyday activities and also how one data set can answer many different questions. So here we see cumulative distance, we see average speed, and we see type of ride happening. And our suggestion is if you want to get started with learning more about data and how to visualize it, how to work with it, how to clean it, people usually find interest in things that they're doing themselves. So this person is tracking their own bike activities. A lot of people track their steps. Some people could just track, how many books you read or how many pages you read. Any kind of activity that you do on a regular basis, you can just start keeping track of and starting to put down in a spreadsheet. And then after a while, you could start making charts like this to visualize what has happened over time. And it's up to you what you want to track and how often you want to check in on it. It could be taking a data point once a month, so that's not a very big commitment, or you could do a data point once a day, depending on what you're measuring and what you're interested in. And yeah, inspiration like from the subreddit is great, so you can start seeing other people's ideas and maybe get some inspiration from them. So as our, this is not going to be as impressive as the last charts, but for our demonstration today, I wanted to start with a poll. And this is just something to get a little bit of information from you all so we can have a little bit of shared interest in what we're visualizing. So I'm going to launch this poll, and it's basically what pets do you have? And you can choose one of these answers. Should be able to start it from here. And I've set it up so the poll will display the number of results, which is important for our next step. Usually in polls like this, you'll see percentages, which could work as well. But with the raw numbers, we can always create percentages in our visualizations. So as you all answer that, I'll start setting up a spreadsheet and entering columns and values. And then we will start creating a data visualization together. So this is a very simple approach to this process. We're cutting out a whole bunch of things about talking about proper data collection, how to do it so it's representative, thinking about what you're collecting and how you're asking questions and framing the answers, making sure the answers are representative of everything that's possible, stuff like that. So those are all a lot of considerations to think about when doing research. This is just a very brief example for kind of for fun. So in this instance and in the next instance, I encourage you to follow along. If you have access to a Google account, you can go to Google Drive, and here it's being displayed as docs.google.com or drive.google.com will take you there as well. Go ahead and create a new spreadsheet and title it, and then we can move on from there. So let me open up, I have to see my Slido again to see what the numbers are like. All right. So it's important to name your spreadsheet, so you can do that up here. I usually like to include the date of the whatever day it is. That way, if I start working on it again in a week and I update it, then I know which version I want to use. You can also put a version number in there if you want, but putting a date is very helpful in the future to be kind to yourself to understand when you did what. So now we can set up our columns. So the variable that we're asking about are different answers. So we had dogs, cats, cats and dogs, other and none. And what we're looking at are categories of pet ownership here. So I can put something like categories as my column header. And so that's my variable that I'm looking at. I'm going to put it in bold. I use Command B for that or Control B, just because it makes it a little bit easier to read if you have a bunch of columns, and it doesn't affect like graphing or anything. The other things that we're collecting are numbers. So we only have two things here. We have A, B, C, D, and E, and we have the number of responses that everybody gave. So we can put counts or numbers or whatever you want to call it. And then we represent what the data that we have are. So we have dogs as a choice, cats as a choice, cats and dogs, other, and none. Now I'm looking at the results in Slido to capture these answers. So one thing you want to do when you enter data is to make sure it's formatted correctly. We talked about different types of formats. So it could be text, it could be numbers. One thing that happens with spreadsheets is it automatically interprets a lot of what you're trying to do. So if you put something that looks like a date, it might just change it to a date. So you really want to understand what's going on in the program and be in control of that process so you know what's going on with your data. You can also turn off a lot of those automatic things. So if it keeps formatting something to a date and you don't want it to, there's a setting or option to do that. But since these are numbers, I'm going to go in here and make sure that I'm able to tell it, the program, that this is actually a number. So what we're doing in the spreadsheet, you basically highlight what you want to work with by clicking and dragging. So then the highlighted cells will be the one we're telling to format. And then in Google Sheets, you want to go through the format menu here. So we have a lot of different options. So we have text and number. I'm going to choose number, and it's, it's set to automatic, so it kind of detects what you have. But just to be safe, I am going to put number in there. You can choose from a lot of different numbers too. So if it is financial or otherwise, you can see what's going on there.
Also, Justin, we have a quick comment. Would you be able to enlarge your screen size?
I think so. Yes.
Thank you.
Is that better?
Yes, much better. Thank you.
Alrighty. So I was up in this format menu and doing number and number right there. What this did was automatically put decimals after the numbers. We can get rid of these since visually, and accuracy, we have integers here because we're each one person and one vote, so we don't really need the accuracy of 2 decimal points. So we have tools up here that can increase the number of decimal points or decrease. So I am going to click this a couple of times just for the sake of visuals and not needing that sort of accuracy to make sure it's down to just whole integers. All right, so the easy way to get started here is to go ahead and highlight what you want to create into your chart.
Hey, Justin. I think we're getting a few comments. I think the dog number, I think that's 18.
Oh yeah, that's a great point.
Yeah.
I don't know, maybe I just did something
It'll
wrong
affect
on
the
my
visualization. So yeah.
keyboard.
Thank you.
Checking again. We've got another answer here. All right. Live processes. So we have a drop-down menu here since I got so large on you. In the toolbar, you have a chart button right here. It looks like a bar chart in the preview. And what we're doing here is basically highlighting all of our choices and numbers to see what's going on. Actually, I can highlight everything and insert a chart. So I'm going to zoom back out a little bit. What we automatically get is a pie chart here, and it's also showing percentages. So this is just what it decided to show off the bat based on what we had available. We can also decide to put it into a bar chart, which I tend to prefer with this kind of format. I mean, it's up to personal choice, and there are some debates about what graph is best to use here. But here you get to see a bit of a cleaner kind of comparison between, which category is very big versus very small. And you have your axes labeled here. So the categories they automatically put down here from the first column, and then the counts they put over here from the second column. There are a lot of number of things you can do with the customization of this chart, including the color of the bars, whether or not you have the counts actually written on the bars and everything like that. That would be more of like another hour or two we could spend on customizing charts. But I did want to show you one thing here. Now that you have this chart created, you can actually, it's linked to your data directly. So if you end up updating your data, for example, to 20 instead of 18, that will automatically reflect in your chart because it's linked in the software. The other thing you can do is if you're very interested in how the bars are displayed in what order, you can actually go and highlight everything in here and change the order. So what I can do is highlight all the categories and counts. I can go into data, and it's called sorting. So if I sort a range instead of the whole sheet means I grab everything and I sort it whatever way I want. But I'm not really changing where the column headers are going. So I'm just going to sort a range, which is my selection here. So the automatic choice for sorting a range is by column A, but I actually want to sort by counts. So if I sorted by column A, it would just do like A to Z, dogs, cats, and everything. I don't really want to do that. So if I go into sort range and advanced options, I can drop down to column B, which is the numbers, and I want to sort from small to large or large to small. So this will be from A to Z, which with numbers, it doesn't tell you, but it means from small to large, or from Z to A. So if I sort like that, then you can see a sort of clean sweep up to actually a very clean curve here from other all the way up to none. So the most people responding have none, and then the second biggest group is cats alone, and so on from there. So that gives a little bit of ease to your viewers when they see something like a progression like that. It's a lot easier for them to make associations like that, as opposed to looking and comparing the heights that are more jagged. And it depends on your data and sort of what kind of thing you're trying to show through your graph. But these are things that we think about when we start making visualizations. Okay, so the thing we're going to do now is trying to do another example and are asking if you would like to do this to create your own chart. So we're going to do another poll, and we're going to give a moment to create your own sheet and your own visualization. So feel free to enter your answer to, do you prefer chocolate or vanilla, without any context, which I know is very wild. It could be anything from candy to ice cream or whatever. Um, but I also included this third answer because when we first did this class, some people are very upset about chocolate versus vanilla. So I gave you another option if you don't prefer either. So what I'm hearing from the attendees is that you are able to see the results. I can also type these into the chat so you have something to work off if you can't see those. But what we're asking here is for you to go out and redo what we just did in your own spreadsheet program and see what you come up with. Maybe it's a pie chart, maybe it's a bar chart, and see what the answers are looking like. So this is fairly straightforward, three answer kind of thing. But if you start doing your own data collection or you have a longer survey, you're going to have to start thinking about how to represent data accurately and appropriately in graphs.
Yes, thank you all for the questions. I would ask also too, Manaz, could you explain a bit on the items in different months? In the meantime, yeah, we have a few Excel questions. In the meantime, the question on same functionality, Excel Online versus desktop, I believe it's all the same. I just now know if you're aware of any functionality differences between those two.
What is the functional difference between Google Sheets and Excel?
Actually, we see that one and also Excel Online versus the desktop app.
Oh, yeah. So Microsoft has started putting everything online as part of their cloud systems. As far as I know, many of the features are the same, but I think there are some small little things where you can or can't do them in the online versus the full program. I'm actually not too familiar with the online one. I still use the desktop Excel, so I don't really know the answer. There might be some differences that I don't know about. But in terms of Google Sheets and Excel, the Google Sheets obviously have built their product around Microsoft Excel to the point where you can upload an Excel spreadsheet into Google Sheets and it'll work right out of the box. So they're definitely following Excel's lead with all this stuff. And there's a lot of similar functionality between two. So I think using Google Spreadsheets or using Excel is a very similar process. There's not going to be a steep advantage over one or the other, except that Excel desktop, you don't need the internet connection. So if you need to work offline, you can do that. Google might have that option too if you have like a paid account, but I can't remember. So we'll just walk through very quickly in this example in Excel since a couple of people are asking about that. From your Home tab, go over to Insert, and then you can do recommended charts from here. So you can do a column, you can do a pie chart, and you can do let's do that one this time. So we have a horizontal bar chart, which I sometimes like to do if the categories have very long names. It's a little bit cleaner to look at. In terms of sorting and changing the The rows by sort, you can do that under data as well. So data sort, and then there's also a filter option, which is pretty cool, but we don't have time to go into. So if you go data sort and then sort by, you would do sort by counts and smallest to largest here or largest to smallest. So now this data is linked to the chart and anything you put in there will change. Also in your spreadsheet, you can copy this chart just hitting your Control C or Command C and then paste it into PowerPoint, paste it into other environments. You can do that in Google Charts as well. And often they link across documents as well. So if you have it in a Word document and you want to update it here, you can usually do that and they'll connect. All right. Any other questions? I see a few, but I don't know what all we've answered so far. I think we're doing pretty well.
Yes, I've answered a question about tracking things over different months.
Okay, great.
And if the month is the unit on which the importance of the tracking is really hinging, then I would say, yeah, do have a different column for every month. And otherwise, just some questions, or I'm seeing questions about inserting charts, creating charts in Excel, transferring something like a chart made in Excel to a PowerPoint slide.
Okay, great.
Some of that can be sort of copy pasted. And as I see somebody using the Excel 365 is clicking on Analyze Data to create charts. That can be very helpful.
So what is neat is they built a lot of automatic processes into these programs. So sometimes it'll ask if you want to convert your spreadsheet into a table. That gives you some more options, makes it look cleaner. And they'll also do automatic graphing and things like that. So this last little part of the class is talking about some further resources in this area. Like I said, a spreadsheet class could go on from here into probably several hours. So I'll mention a few things and then also give you some contact information at the end. If you have specific questions, you can feel free to reach out. But these are some ideas for where you can go to get started if you want to go in different areas. So not just spreadsheets, but just if you want to grow in different areas in this data services or data work or research, we'll list some options here. And again, these are available as links from our website. We did build a guide to working with data in libraries as librarians, and it's called the Data Pathways. So there are a number of different classes that we offer through NNLM on data, from topics in research data management, data science, and open science, things like that. So we created one guide on our website, Data Pathways website, to help you navigate these. And you'll see different generalist versus data management, data science tracks. Those are just suggestions. You can do things in any order you'd like. But these are showing you sort of broad understandings of data librarianship and what librarians tend to work on when they work on data services for researchers and for their campuses and communities. This is newer, so we have a Zenodo page, which is a repository where a lot of people use it for research materials. So Zenodo is a tool that's an open repository, general purpose, where people can put their papers and data sets and research data and software and reports and things like that. But we started using it to put our class materials. And the class materials are slides and videos, recordings, like we're recording this today. We'll put that up there. And any scripts and other resources we have from our classes will go into Zenodo all in one place so people can find all of our classes and materials on that website. We also have an NNLM YouTube page, and this is ongoing for everything that we do there. So there's a lot of data classes, but also a lot of other health sciences classes. So feel free to check that out. And we have our specific playlist for the Data Services Center there. I'm going to just list a couple of classes here as general introductory classes to give you an idea of the scope that we've been doing. These are available as recordings, and some of them may be offered in the future, depending on what we're able to do this coming year. So these are the most introductory classes. We have on-demand classes that are available right now at any time, and they're asynchronous, so you can do them at your own pace. And so recently we created this Data Services on Demand course, which has 4 modules, and they include research data management, research data sharing, supporting open science, and looking at data ethics. And so those are a really good crash course in what data librarians do and the topics that we talk about and work on together. There are also different on-demand classes across NNLM on different topics, listing here stuff on health data standards and common data elements, and just a lot of things in this area. There's also a lot of recorded webinars on YouTube and on our website. A few of these are highlighted here: Making Sense of Numbers, which is communicating numerical health information. And that might be actually a really good place to go from this class, since it's sort of the next step of like, what do we do with these numbers? Health Statistics on the Web, which features on finding and exploring health statistics, and our Research Data Landscape class, which talks more about what librarians do in this area and how to build successful data services. We also recently launched 2 classes in understanding statistics, so not necessarily running statistical tests, but seeing what other people have done with their data and understanding what kind of things can happen with that. So successes with statistics, and also some of the things that could go wrong with statistics, or overstating your findings or having statistical errors. So if you're interested in that, we have a 1-hour webinar called Greatest Crimes in Statistics that goes over the high level, and then we have an on-demand course that goes over more of that in detail. In terms of skill building and research data management and other topics, we do have a research data management on demand. We have a DMP tool class, which is all about this tool that helps you create data management plans. And we have open tools for data de-identification, which is about cleaning data and making sure people aren't able to link data points back to individuals. And then we have a newer Open Refine class, which is another class around data cleaning, and talks about this tool called Open Refine, which can be used on spreadsheets to clean out redundant or missing data or other things like that. You can sort of delete stuff that you don't need and go from there. I do see some chats going on. I'm just going to keep going though, and we'll have time at the end to address some of those questions. We also had a big push around the NIH data management and sharing policy. We generated a lot of materials and resources and recordings around this. So this is something that went into effect in January 2023 and still is receiving updates and is impacting a lot of people who receive grant funding from NIH. And it's basically the idea that everybody needs a data management plan, and there's a specific way to craft that and update it and keep current with it. So we go through all of the features of creating a data management plan around this policy in different formats in the classes listed here. If you're interested in some other topics working with data, so we showed you like just putting information into a spreadsheet. There's also a lot of advanced things in Excel and with computer programming that you can do to search through data, especially if you're working with bigger data sets. You might want to use Python or R or something else that can more easily handle very large data sets. If those are kinds of things where you want to look into, there are deeper dives from other organizations that we can recommend here, particularly the carpentries. So they have a lot of information on learning computer programming and applying it to data sets in different areas. There's specifically a library carpentry if you're interested in that, data carpentry, and software. These other 2 are courses that are around data services and research data management that happen. The Research Data Management Librarian Academy is ongoing and open. You can just enroll and start right away if you wanted to. And this other opportunity is, I think, an annual offering. I don't know if it's been announced yet for this coming year, but is usually something that runs for 10 weeks and is an application and approval kind of process. Here are some other links to further resources. So a data literacy project, which offers free courses on data foundations and informed data decision making. It is a little bit more business focused. The Georgia State University Library has research data services micro badges for becoming data ready, and they have recordings of their workshops and other things. A few places do share these kinds of things too. So if you're searching around and see libraries sharing on data services with recordings, those are great places to look. And then there's an article that discusses how to become data literate and how to learn about data to enhance your communication skills, critical thinking, and research skills. It's not enough to just collect data and clean it and make a visualization. You have to understand where it came from, what limitations it has, what you can actually say with it, and how to communicate that visually to your audience. This slide contains some links to glossaries and other resources. If you're stuck on data terminology, we have a data glossary that explains a lot of things like data enclave and things like that, terms that are used in health sciences research. And as I mentioned, we have a general email address. So if you have any questions or are looking for additional resources, maybe you're like, hey, I want to study XYZ, I don't know where to go, feel free to drop us an email. We'll check around and see what we have or what others have and get back to you with some recommendations. We also have updates on our blog. So if you're interested in our upcoming classes or staying up to date with what we're doing, for example, we have an internship we run every year for graduate students, things like that. Feel free to subscribe to our blog at NCDS. And we also have a LinkedIn page for NCDS, which is where we also post updates and connect with people. I'll go ahead and stop sharing so I can see the chat more easily. I also want to include here, as we start looking at questions, we have a survey, and this is a way to claim credit if you like continuing education credits. But it's also a way for us to hear from you. So what else do you want to see? Do you want to see another class on spreadsheets that goes a little deeper? Do you want to learn about formulas? Do you want to learn about macros, other things like that? Feel free to fill out the survey. We'll take everything into account. And your feedback is very helpful. We use it a lot to formulate new ideas and approaches to classes. So thank you for attending. We do have a few moments here to answer some questions. If you have them, please place them in the chat. Is there anything we should address that you've seen so far, Sarah? Oh, I think you're on mute.
Sorry. There's just one of the most recent questions on a link on screen for a data literacy article, if that could be
Yes, I'll place this in here. It is from the website Tableau, which is also has a free version of their software for creating data visualizations and dashboards. Tableau is a great program too. It's just a little bit more of a learning curve, so we don't currently have a class on that.
Okay, thank you.
I need an R programming for dummies, slow tutorial Zoom. Does that already exist? The data carpentries is the first thing I think of when it comes to R programming. I think they have a couple different lessons on that. But there are YouTube videos for R programming. It usually helps if you put in a concept or put in a topic. So I want to use R programming for basic statistics or for whatever subject area you're in. Or I want to learn about data cleaning with R programming, or I want to learn about whatever concept you're looking at, loops or whatever thing you're looking at. It helps to be a little bit more specific if you search on YouTube for that. Right. And as others said, there's a lot of links on our website. We'll also email out everybody who registered with links to our handouts, which has all of the resources we talked about today. Oh, data decolonization is a great topic. It's not something I am super familiar with, but it is worth mentioning. Thank you for bringing it up. There's a lot of great movements around data representation, and who controls data and who collects it and who publishes it and who has access to it and things like that. So I think data decolonization related topics are very important. I just don't know enough about it to give it a good viewpoint here. If anyone else knows anything and wants to put in the chat, I welcome that. But it is acknowledging that, representation matters in data, and who we collect from and how we represent it is very important.
There's also a question up above about, is there a sort of manual on how to do spreadsheets that we know of?
Ooh, that's a good question. Not off of the top of my head. There are quite a bit of data books that are open. So if you look at an open book repository, or if you search for like copyright-free spreadsheet book, or visit your local public library, you'll probably be able to find something around that. I'm guessing that it'll go by platform. So there's probably a book on Excel, for example. There's probably not a generic one on spreadsheets. It'll probably be Excel or the Open Office or LibreOffice. There'll probably be one on Google Sheets. And there's probably some free ebooks out there. So if you search like Open Textbook, Excel or something, you should be able to find something. Excel for Dummies, somebody's mentioning in the chat.
Mm-hmm. Also, if some folks may have available through their employer resources like LinkedIn Learning or those type of things, there's often spreadsheet training programs within those.
Definitely. And I mean, I'll mention YouTube again. It is kind of the Wild West because you'll see varying levels of quality in tutorials on YouTube. But if you find some good ones, they're usually really good. I don't know anyone off the top of my head for spreadsheets, but that is one place to look as well. Teach Yourself Excel is an awesome book, and they have books on how to utilize Google Apps. Thank you. And yes, public libraries, some of them do have access to LinkedIn Learning and other learning platforms. Udemy, Learning Express Library, and LinkedIn Learning. Yeah, thank you for the suggestions. Yeah, definitely promoting local libraries and resources. A lot of local libraries will also have basic classes in computing, and some of them in spreadsheets or business or other things like that. All right. Well, as I said, feel free to reach out via email if you have specific questions. We'll take a few more minutes to look it out and email you back some references for that. But we appreciate y'all joining us today, and please give us your feedback on what you might want to see in the future. Thanks, everybody. Have a good day.
Thank you.
Thanks for watching. This video was produced by the network of the National Library of Medicine. Select the circular channel icon to subscribe to our channel, or select a video thumbnail to watch another video from the channel.